chapter 6. We're talking about proportions in triangles. So we have this side splitting theorem that basically says if we have a triangle and we have another line that intersects two of those sides and is parallel to the third. So here's our triangle, and we have a line that intersects two sides of the triangle right here, and it is parallel to the third side right here. Then that splits those sides proportionally, right? So we can write a proportion XR over RQ. So I can write it like this. This side over this side is equal to this side over this side. And I can flip those around and do different things with those. Okay, and then of course, here's the proof that you probably don't care about. That explains it and how you get there, because it is a theorem, so it needs to be proved. And so there, it's proved, and you could pause this and look through it, but you're not going to. So let's move on to problem number 1. We're going to use this side splitting theorem, and we're going to solve for x. Okay, so we want to solve for x here, and then we can figure out what the sides are. So we do have a triangle, and we have a line going through that triangle connecting two sides, and it is parallel to the third, so therefore it's proportional. So we can write 12 over x plus 1 and set that equal to 9 over x. And then we can solve this. So we get 12x equals 9x plus 9. Subtract 9x, right? We're just solving for x. We get 3x equals 9, divide by 3, so we get x equals 3. So this side, x equals 3, and this side would be x. 3 plus 1, which is 4, and we can see that that's true, right? That would be answer of 3, and this would all be the answer of 3, right? So it is correct. And then so here's the problem that I want you to do. So you're solving for a, so set up your proportion, right? What goes on top of this side, and then go ahead and solve, take the cross product, right? And then solve for a. And then this bottom part, you're just thinking about in a triangle, x, y, z. So you could do that. You could label this x, y, z, and then you have rs joins x, y, and y, z. So kind of like this line right here. This line right here would be rs. Okay. And then you're trying to figure out same thing like this. If my proportion, this to this, equals this over this, if that equals 1, what must be true about rs? Okay, what about rs must be true? Okay, so maybe you can think about that, maybe you can't, but there you go. There's the first video.